Science Mr. Robertson, back in action. And going back to the very beginning of Earth history. Now, Earth is around 4.5 billion years old. That's 4,500,000,000 years old. It's older than me. Older than I'll ever be. And our Earth, in those early days, was a crazy place. Volcanoes everywhere. Asteroids hitting constantly. Thunder and lightning. This place is getting very exciting. We have warm waters. We have steam coming up. We have huge clouds. We have all these volcanoes making new rocks and lava all over the place. The early Earth was a crazy, crazy place. Somewhere in this crazy, crazy place, something happened to make something quite wonderful. Life. Now, we don't exactly know how. We don't know why. We have ideas. Basically, we've been able to reproduce experiments in labs. And what we've been able to do is to make warm water, make huge clouds, and make thunder and lightning happen with all the different little things that would be on the Earth. And you take them all together, and it is possible. You need a lot of luck to get the right things in the right place. But we are able to make simple genetic codes. Simple versions of DNA, the code that makes our body. The code that makes any living thing body. So we think that some lightning bolt hit some chemicals and it turned into this chemical, this DNA code, and this DNA code wanted to make more copies of this DNA code. So it managed to make itself again, and again, and again. And this might have happened many times and failed, but at least one time it worked. And we got the life that exists around us now. Happened very early. We know it must have happened by 3.5 billion years ago that we got the first life. Could have been even earlier, but there's no evidence for that. But we can be very sure that there would be life so long ago. Now, that life 3.5 billion years ago, that life would be life in its most simple form, and that would be bacteria. Now, bacteria are made of one cell. Not like this usually. Have a nucleus in the middle, which is where the genetic code is. They might, if they're lucky, have some little things to move with, and a few little things here that maybe they make energy move. That's about it. They are as simple as life gets. And we think for most of the time, we're going 3.5 billion years, probably even down to, 1.5 billion. Then life was this. It was small. It was simple. These things here are green because what did they have? They had chlorophyll. And they had chlorophyll because how are they getting energy? They were doing photosynthesis. Now you should all know that there'll be a question on photosynthesis attached to this video. And it did this in a place, photosynthesis, one of the things it needs, give it you now, it's going to need water. Life evolved in the sea. And it only did this. It only did this idea of photosynthesis to make energy because our early Earth didn't have much oxygen. The oxygen level on Earth has been going up through history. It used to be really, really low. Like, carbon dioxide now is at 0.03, maybe a bit more than that because you burn too many things, percent. Oxygen used to be like that. Now oxygen is at 21%. Oxygen levels in history of the Earth have been going up all the time almost. Because these plants have been making it. These bacteria have been doing photosynthesis for so long. Eventually, when you get to around here, some of them can use oxygen for energy. Eventually there's enough oxygen that some bacteria can do that instead. But most of the bacteria that I'm talking about still were doing this process here with the chlorophyll to get their energy from the sunlight. They're in the sea. We do get then an explosion. We get an explosion when we go to around 600 million years ago. And we get an explosion which is called a trilobite explosion. Because all of these different creatures called trilobites suddenly took over. And they kind of look like this. I studied a lot about these at university. And we have lots of rocks, really old rocks, actually old rocks. Right? We're still talking 500 million years ago. These are really old rocks. They look a bit like this. Got like structure over here, structure over here. But what's interesting is that this shows, they're big. Some of these would be the size of my hand. So they're not just bacteria anymore. So we actually have a shell. There is a thought process to this, there's protection to it, which suggests all kinds of different things are going on. You need protection. So there must have been predators and prey happening by this point. Of course, you've got the size here. The size is much bigger than bacteria-shaped things. We don't understand why. One cell going to two cells, why would that happen? We think maybe it could have been that one accidentally got pushed into another one. It's like, oh, you're inside me, but this is good. Let's keep it up. Or maybe one bacteria tried to make two bacteria. When bacteria make babies, they're not babies, but make new copies, it makes two. Maybe it didn't work, and they came together and they got stuck, and they were like, hey, this is pretty good. Let's stay as two. We don't know. We weren't there. But something happened to make life go from two cells. It's very easy to go into many cells. And then life could turn into big, different things. And it could become diverse. You would get a whole explosion. And this trilobite explosion were all of these different shaped things of these shells here. And they've got a whole record of the fossils to check on that. Fossils? Fossils. Fossils are so important when I talk about evolution because fossils are the dead remains we have. It could be bones, famously, but it could be skin, it could be imprints in the rock, anything that tells me that there was life living here, the hardened remains. I can even have fossilized footprints, a footprint made of mud that stays there. What is beautiful about fossils doesn't just tell me the shapes of what things were, but I can also, if I have a bit of rock like this, and maybe I'm here, Not always. Not always, but this rock is the youngest. And then it gets older and older as you go deeper and deeper and deeper. So you can see how life has changed through time by looking to see how low the rocks are. And yeah, rocks get twisted by earthquakes and things, but as a general rule, that's a really effective way. And I'm going to end this here by we go from trilobites with the fish, with gills being able to swim. And then all of this happened in the water. The amazing thing happened next. And the amazing thing happened when some of those plants found a way to make roots. And the benefit of roots was that rather than having to float on the water's surface, they could then go on land. Our next video will look at that in more detail. How life goes onto land. And we'll look then at some of the biggest living things we've ever had on our planet. Thank you very much.